Hey everyone, I recently started practicing data structures and algorithm and I thought I should upload videos on YouTube so that I can understand and explain a problem and its solution in a better way. Today we will be solving the very first problem in this hash map series, that is the two-sum problem. Also, it is one of the first problems that we will find on Leetcode. So the question states that we are given an array of integers and we need to return the indices of the two numbers such that they add up to a specific target. Also, we need to assume that we would exactly have one solution and we may not use the same element twice. So let us look at the example first. So here we are given an integer array that is 2, 7, 11, and 15 and a target value that is 9. So we need to first check which two elements are basically adding up to 9. So here we can see 2 plus 7 is equals to 9. So we will be giving the indices of 2 and 7 as our output. So that is 0 and 1. So we should always think about the brute force solution first. So in the brute force approach, for every element in the array, we would check in the right half of the array whether the difference between the current element and the given target is present or not. So we will first keep our pointer on 2 and calculate the difference of 2 with 16. So 16 minus 2 is equals to 14. So we will check for 14 on the right hand side of the array. So here we see that 14 doesn't exist. So then we will move on to 4. We will again find the difference with the target. Then 16 minus 4 is equals to 12. So does 12 exist in the right hand side? No, it doesn't. So again we will move on to the next element, that is 7. So we will find the difference again. So 16 minus 7 is equals to 9. So we will again traverse through the array and yes, we see that 9 exists in the right side. So we will be outputting the indices of 7 and 9, that is 2 and 4 as our output. Let us go through our code once and see how we can implement the brute force approach. So here we have first declared the resultant array to store our indices. We will keep a basic check if we have been given an empty array or not. Then we will be returning the result. Then we will start off with the first loop where we will be keeping our ith pointer at the very beginning of the array, and then we will find the difference between the target element and the element that is at the ith position. Then we will move on to the right hand side of the array and keep checking whether the difference is equals to any element that is present in the right hand side of the array or not. If it is present, then what we will do is we will store the indices of those elements, that is I and j, in our resultant array and return that resultant array. The time complexity of this solution is O of n square and the space complexity is O of 1. Since for every element we are checking the whole array, traversing the whole array, that is because the time complexity would be O of n square. So we should now think about optimizing our current approach. So we can optimize it by using a hash map. So in the hash map, what we can do is we can store our element and its index as key and value pair. And then we can keep on checking whether the difference number exists in our hash map or not. So what we will do is we will again start off with the first element of the array and then we will find the difference. So 16 minus 2 is equals to 14. So here initially we can see that our hash map is empty. So we will do nothing and just insert the element 2 and its index in the hash map. So we will again move on to the next element, that is 4. Find the difference, that 16 minus 4 is equals to 12. So here we see that 12 doesn't exist in the hash map. So what we will do is we'll simply insert 4 and its index 1 in the hash map. So then again we will move on to the next element, that is 7. So we will calculate 16 minus 7 is equals to 9. 9 again doesn't exist in the hash map. So we will insert 7 and its index in our hash map. So we will continue till 8, again it's the same process. Then 9. For 9 we can see that 16 minus 9 is equals to 7. So does 7 exist in the hash map? Yes, it does. So what we will do is we will return the ith index and the index at which 7 is present, that is 2. We will extract it from the hash map and then we will return it as our resultant array. So basically the time complexity of this solution will be O of n and the space complexity will also be O of n since we are using a hash map. So the time complexity will be O of n, because we are ignoring the condition for collision here. Since in average case there will be no collision, and we will be inserting and searching the element in our hash map in O of 1 time. So let us go through the solution of this approach once and see the code. So again, we have done just like the previous solution. We have declared a resultant array, a basic check. We have declared a hash map, and then we will start off with the first element of the array with our ith pointer. Find the difference with the ith element and the target element. Then we will check whether our difference exists in the hash map or not. If it exists, then what we will do is we will simply insert the ith value in the resultant array, and we will get the index of the other element from our difference if it exists in the hash map, and store it in resultant array again and return the resultant array. Otherwise, if the element doesn't exist, if the difference doesn't exist in the hash map, what we will do is we will simply insert the element and its index in the hash map, and we will keep on doing it until we find a particular solution. So this was the two approaches that we discussed today for the two-sum problem. Hope you all like it. Please do give me feedbacks so that I can improve further. Thank you.